Howdy, everybody. Hope you're doing well wherever, whenever you are. Sorry, just had to check my whiteboard. Sometimes my kids draw on it and they put some weird stuff on there. So, yeah, and I just saw in the thing it looked like, but no, it was all erased. So, anyway, I hope you're doing well wherever, whenever you are. Did I say that already? Regardless, I mean it for sure. So we're doing Advent to Code day 23 for the year 2016. We're almost done. The way I'm recording these is, I'm like several days ahead. You may start to see, if not now, maybe already, that I'm pushing out more than one a day. We'll just see how it goes, because I definitely want to get all of this stuff done by the time Everybody Codes comes out. And I also want to record maybe practicing some of the Everybody Codes, just so I get an idea of how Everybody Codes works versus Advent to Code. So anyway, if that sounds interesting to you or not, I'd definitely love to hear your opinions. I think I also mentioned before there's like a Caddis website that is more geared towards like how competitive programming works. So if that's something you're interested in too, maybe we can find some of those to solve. So anyway, just let me know. Otherwise, let's get started with the day. Safe cracking. This is one of the top floors of the nicest tower in EBHQ. The Easter Bunny's private office is here, complete with a safe hidden behind a painting. And who wouldn't hide a star in a safe behind a painting? True. The safe has a digital screen and keypad for code entry. A sticky note attached to the safe has a password hint on it. Eggs. The painting is of a large rabbit coloring some eggs, UC7. When you go to type the code, though, nothing appears on the display. Instead, the keypad comes apart in your hands, apparently having been smashed. Okay. Behind it is some kind of socket, one that matches a connector in your prototype computer. You pull apart the smashed keypad and extract the logic circuit, plug it into your computer, and plug your computer into the safe. Now you just need to figure out what output the keypad would have sent the safe. You extract the SimBunny code from the logic chip, your puzzle input. The code looks like it's almost the same architecture and instruction set that the monorail computer used. You should be able to use a SimBunny interpreter for this as you did there, but with one new instruction. Toggle X toggles the instruction X away, pointing at instructions like J and Z does. Positive means forward, negative means backwards. Okay, so you could have like a negative toggle and go back, and a positive and go forward. For one argument instructions, ink becomes deck. What was the copy ink deck J and Z? Oh, this was the Fibonacci one, huh? So you copy ink deck jump not zero, and then they want to add toggle, where one argument increment becomes decrement, and all other argument instructions become increment. For two argument instructions, jump not zero becomes copy, and all other two instructions become jump not zero. The arguments of a toggled instruction are not affected. Okay. If an attempt is made to toggle an instruction outside the program, nothing happens. If the toggle produces an invalid instruction like copy 1, 2, and an attempt is later made to execute that instruction, skip it instead. These I probably used like an enum, and these would have required to be like registers, I guess. We'll see. Anyway, we'll have to find some way to check to make sure an instruction is valid, it says. If toggle toggles itself, for example, If A is 0, toggle A would target itself and become inc A. The resulting instruction is not executed until the next time it's reached. So you still like move the program counter ahead. For example, given this program right here, copy 2A initializes registers A to 2. The first toggle A toggles instruction A 2 away from it, which changes toggle A to inc A. So this becomes inc A right here. And then this becomes copy 1A. Oh, J and Z becomes copy and all other become J and Z. So this copy becomes a J and Z jump not 0. So this is now inc A. So A is now 3. This is now jump not 0, 1A. So it jumps. Yeah, it jumps ahead, skipping the 2 deck check. So this is jump not 0, 1A, which is 3. So it skips to the end of the program. Okay. In this example, the final value in register A is 3. The rest of the electronics seem to place the keypad entry, the number of eggs, 7, in register A. Run the code and then send the value left in register A to the safe. So we set A to 7 and run the code. Okay. I mean, I feel like we should just start with copying and pasting this code. So day 12. So yeah, we have a value. Yeah, you can see here I have like these ones have to be U sizes, but now they could all be values. Is this one where I didn't like how I did it? I mean, let's just, we'll copy it for now. What is this convert register? What did I use this for? Yeah. All of these have to be values now, and I just have to make sure they're correct. like that. I think I just have to do this for all of them, don't I? And then I had to check them as we're doing our thing. That. That. Okay. So we got our parsers. We got our convert register. It's used here. Oh, I must be using an array for ABCD. Okay. It's like these ones where I feel like copies X, either an integer or a value. So this one's okay to register Y. So this one needs to be a register. This one needs to be a register. This one needs to be a register. So can I just wrap these in? Like if let sum r equals value register r. It's not quite like this, but it's like that's what I want to do. Is it like this? That's an eye size. Oh, we're gonna panic because we haven't done toggle. Okay, but I think I've got that part figured out, so it's just the toggle now. Toggle X. So we need to add a toggle value. Toggle. And we need to do a toggle here. This one is going to be interesting. Oh, it's called match input. If pause less than 0 or pause greater than equal to input dot len, we continue. I don't actually want to do that because I want to jump the PC down here. I mean, I can do it right here for now. Do these work above? Yeah, I think they do. Like I try and evaluate, I try and do it, but if I can't do it, then I, stop and or I just fall through and then do this next. So those ones are okay. This one, what I wanted to do is like short circuit and say, hey, if I'm out of bounds, I don't do anything. But then otherwise I match on the input dot pause. And it's like instruction toggle V. And then what are the rules? All one argument instructions, inc becomes dec, otherwise it becomes inc. So we go instruction inc v. So there's probably a bunch of these. Inc becomes dec, dec becomes inc. Inc, dec, toggle are the three. So we have jump not 0 and copy. Jump not 0 becomes copy. But then copy, everything else becomes jump not 0. And all other 2 instructions becomes jump not 0. So that's copy and toggle. Becomes Z. wait, no, I've already done toggle. What 2 argument instructions are there? Copy and jump knock 0. Okay, so these just swap. Implement clone. And yes, this needs to be mutable. So we'll say let input equals oh, that is right. This one won't ever be 0 when I convert it up here. And this is actually not right. This is like, this is my move. So this is my delta. And so I actually want to say let next equal PC plus delta. And then I say if next is this or next is this. This? Oh, these are. Oh, I do toggle twice. There's only 5 instructions, is that right? So this one is if I it seems like it's running forever. Hold on 1 second. Okay, it seems to be running forever. Why would that be? Are these if-lets correct? I think it is this if-let. If let value number and yeah. So these do feel right. Oh, I'm supposed to set the register to something, huh? Maybe that's it. Set A to 7. What happened here? Copy ink deck jumped on 0. I must have just copy and pasted that wrong. Oh, okay. It's coming back now. Really fast. Hopefully that's a good sign. That is the right answer. Okay. I don't know why it was going on forever. Oh, it was going on forever because I didn't set the register to 7, A to 7. So, okay, part 2. Part 2. The safe doesn't open, but it does make several angry noises to express its frustration. You're quite sure your logic is working correctly, so the only other thing is you check the painting again. As it turns out, colored eggs are still eggs. Now you count 12. Okay. So A is now 12. As you run the program with this new input, the prototype computer begins to overheat. You wonder what's taking so long and whether the lack of any instruction more powerful than add 1 has anything to do with it. Don't bunnies usually multiply? Anyway, what value should actually be sent to the safe? Okay. So I think this is just, we want to set A to 12, but it's going to go brrr and never finish. So we need to do what we did last time, which is like, what is it, like decode input? Maybe we want to decode the input. We want a value of A, which is an I size, and we'll return an I size. I don't think I even really looked at the puzzle input this time around because I think I could just copy and paste from part 1. Okay. Copy A to B. So this is let B equal A. Deck B. Copy A to D. Copy 0 to A. Copy B to C. Ink A. Dec C. Jump not 0. C -2. So you're very slowly making A equal to C. C equals to B. So these three have the effect of like a very slow version of A equals C. Dec D negative jump not 0. D is A. But we're going to jump -5. So 1, 2, 3, 4, 5. Copy C to B. No, C equals B. Like this jump includes 1, 2, 3, 4, 5. So we set A to B, A to C. C equals B. A equals C. I don't understand what this is doing because it feels like it's not doing anything. Do I have this right? Set B to A. So like at this point, B equals 12. B equals 11. D equals 12. For A equals 12, right? For part 2. A equals 0. C equals 11. Inc A, Dec C. Oh, it's A plus equals C. And you're going to do this D times. B is 12. B is 11. D is 12. Set A equal to 0. Copy C into B. So C equals B. Increment A, dec C, jump. So you're going to add A to C. And then you set C back to B. And you do that D times. Decrement B. So B minus equals 1 is this. Copy B to C. So C equals B. D equals C. D minus equals 1. Oops. That's these. Inc C. Jump not 0, D negative 2. So that's these two instructions right here. Jump not 0, D negative 2. Yeah. So this has the effect of like oh, I did forget to do the decrement up here too. Because I'm decrementing D, it gets set to 0. Oh, but it gets reset right here, so that's okay. So like this thing has the effect of like C plus equals D, D equals 0. Toggle C. B is 11. Then B becomes 10. Oh, D. I'm going to toggle C, which is B plus D. So 10 plus C. Wait, hold on. C equals B plus D, which is 10. D equals 10, toggle C. It looks to me like the toggle doesn't do anything. Is that right? The toggle never actually does anything. Like if we trace the values at this point, yeah, C is 20. It's like B plus B, which is 10. So that has no effect, right? Set C to negative 16. Jump negative 16. It's right here. So you're going to do this whole thing over again. But now B is 10. So we're decrementing B. B is our like. B is 12. B is 11. This one's not necessary because it kind of envelops this one is probably what this is saying. Because I'm just going to say A to C times D. Decrement B. Now it's 10, 20. So this is like this whole loop is like while B is greater than 0. And we B, D. I reset it up there, so well, I should, because I actually shouldn't do that because I use it below. But like this thing, so I'm not doing the toggle, so I need to do that in the loop. But this loop is associated with this number right here. So I'm going to toggle 20, 16, 12, 8, 4, and 0. So like 1, 2, 1, 2, 3, 4. I'm going to toggle this one. 6, 7, 8. So these are the only two I'm going to toggle. So this one becomes deck C. And this one jump not 080. What was the rules about? Copy. What is this doing? I increment A and D. Toggle 0 becomes, what does toggle become? Inc. So I'll do one more inc C. Copy negative 16 C. It won't matter because I'll inc C and then I'll set it negative 16 to C, jump not 0, 1. C. I'm gonna 0, 1, 2, 3, 4, 5, 6, 7, 8. Like, I'm curious which numbers I'm changing down here. This looks like I'm just doing multiplication, but it's not right because it would be, this loop never finishes if I don't change this one. So maybe I'm just misunderstanding the toggle. Like, I think we've seen this before. This looks familiar. So I guess I feel like what this is like take 76 and 80, figure out what this is, and then multiply it by 76 and 80. I think the toggle switches this to deck. But then why would this loop be off? So maybe there's something wrong in my inner loop here. This toggle C also has to eventually hit this one too. Oh no, it hits this one. It toggles itself, which increments C. Copy C to -16, jump not 0. No. Toggle C. Like what I'd expect is eventually toggle C becomes 1. And it turns this copy into a jump not 0. Which is -16. And it moves it down here. Maybe it is doing that and I'm just misunderstanding. Let me just make sure I'm moving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did I do that wrong again? So jump not 0, 1, -16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this one is outside. So do I have these right? D equals A. C equals B. Yeah, do you see this loop here? Inc A, dec C, jump not 0, -2, dec D. This is like the equivalent of a multiply, which is what this looks like right here. If I toggle these numbers right here. What is that last bit then? Jump not 0, 1, C. Jump not 0, C, -5, dec C, jump D. Oh, look, I had done it wrong. Now it is doing every other one. Yes. Okay, so my inner loop was wrong. So what's going to happen is it's going to toggle itself the last run. But it's going to toggle this one. So 2, 4, which is this one I got right? It was a jump not 0, but then it turns into a copy. This inc becomes a dec. This inc becomes a dec. Yes. And so this jump not 0 becomes a copy C to 1, which is a no op because of down here. So this literally is 76 times 80. Like that. Okay. I mean, that came back way faster than I would have initially expected. We got it. Okay. Not too bad. Do we know what the inner loop does? My guess is the inputs are based on these two numbers. You're going to take some A. Everyone's going to solve for A the same way. and then you're going to add this multiple, and that's going to give you your like unique input. So like the question is like, what does this inner loop do? Set D equal to A, copy C equals to B, A equals C plus B, C times D, B negative 1. It's doing factorials. I think it's doing factorials again. So this one doesn't actually matter. Yeah, it's doing the B factorial. That sounds weird, but it's doing B factorial. Set D to A, set C to B. Yeah, you're like solving, so D is like what you've done before, and you're figuring out what C is, and then you're like setting the two numbers. I think that's what it's doing. I think it's doing a factorial. So this is fast enough, but yeah, you could simplify this then if it is just doing the factorial. Did the other day do the factorial too? Yeah, it looks like it did, but in like a more complex way or a less complex way. I don't know. Yeah, it's got this loop in here. Does this loop even do anything? I don't think it does. Like this is like a no op because you reset C up above. Yeah, and then like B is your temp. No, C equals B. C equals B. I don't even think you have to do this one because it's like a no op. D equals C, and then you're going to set it up here. Like that whole chunk is a no op. And then this looks a lot more like what we had before. Like this stuff, I maybe this is why it was confusing. The toggle C is definitely a thing. Oh. This stuff is used for the toggle C part right here. Okay, that makes sense. Yeah, okay. Was this error? Value assigned to C is never read. Maybe it's overwritten. It's right here. Oh, C and D are only used inside the loop, is what it's saying. Okay. What do you think? How'd you do on it? Interesting problem. It does, once you've cleaned it all up, like you recognize like it is just doing a factorial here, right? Because you're basically doing like this is the equivalent of like 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 1. And eventually B becomes 0. Oh, the other one I did Fibonacci. That's where I was confused a little bit. The first one I think was Fibonacci. This one's factorial. Okay. And then all this part does is it's just meant to like go through these, and it's gonna like switch every other thing. The toggle does, which turns these into 76 times 80. And again, I suspect, like I think we've seen these before, like these are probably the numbers that discriminate your puzzle input from mine. I don't know, maybe you got a completely different answer, but that would be fun to see. Yeah, and so because this loop is so small and only happens like 11 times, you can see it finishes almost immediately. Whereas I suspect because of all this stuff you're doing, especially this one, this is 80 times 76 loops. And then this one is also kind of like a crazy loop to figure out which one to toggle. Then you've got another loop right here, another multiply loop. So I think that's the hint that it's trying to get at with this multiply thing, right? As you can see, this is the equivalent of a multiply loop like this. Same thing with this one is the equivalent of a multiply. So you just got to kind of see that and figure it out. Okay, that's it. Hope you had fun watching me do it. I'll submit the day as is. And yeah, we'll talk to you next time. Thanks, everybody. Bye.